this method to students? If they given function f of x, so how can you find the maximum value and the minimum value? The given function. Yes. There are two methods. So method one is applicable for just quadratic equations, quadratic expression, as well as modulus function. Okay. Right. Look at here. So here fourth subdivision, which is neither maxima nor minimum, because it will tends to plus infinity, tends to minus infinity. Okay, so because if they given any particular interval, in that case we will get absolute maxima, absolute minima. Interval not given, so let us consider, okay, the interval as real line minus infinity to infinity. When I give the x value minus infinity to plus infinity, so y also becomes minus infinity to plus infinity. So neither maxima nor minima. Okay, then coming to the next one. Yeah. Find the maximum and minimum values if any of the following functions given by. So second question, first subdivision, f of x value is modulus x plus 2 minus 1. See here, since we know that, clearly we know that modulus x plus 2 is greater than or equal to 0, right? So but here the given function is modulus x plus 2 minus 1. It is greater than or equal to minus 1. So adding minus 1 on both sides, we get this is nothing but f of x. F of x is greater than or equal to minus 1. So for every x belongs to R, for every x belongs to R, for each x belongs to R, for every x belongs to R, f of x is greater than or equal to minus 1 means therefore whatever the function having maximum or minimum. Sorry, maximum or minimum? Minimum. Therefore, the function f of x have minimum. Okay. So at what point the function having minimum value minus 1? So to get minus 1, we can make them this modulus x plus 2 becomes 0. So to obtain minimum of f of x, to take x plus 2 value is equal to 0. Whenever x plus 2 is equal to 0, which implies, look at here, x plus 2 is because plus or minus 0, nothing but 0 alone. So x is equal to minus 2. At x is equal to minus 2, the function having minimum, the minimum value is minus 1. Now we have to find f of minus 2.
So you can call it low.
Minus 2 plus 2 minus 1. This is equal to 0 minus 1. The final f of minus 2 is minus 1. So this is the minimum value. Right? Like that you have to write the proper steps. Here simply you can write, we know that modulus x plus 2 is greater than or equal to 0 for every x belongs to R. Is it clear, students? Then what about g of x? G of x. G of x is equal to, look at here. G of x is equal to minus of x plus 1 plus 3. So in this case, what shall we do here? See clearly, in that case, clearly minus of x plus 1. Otherwise, I'll write the steps. So g of x is equal to minus of x plus 1 plus 3. Yeah, here we know that modulus x plus 1 is greater than or equal to 0. But when I multiply with minus, what about modulus? Minus of this value lesser than or equal to 0 for every x belongs to R. For every x belongs to R. So, but here plus 3 is there. Plus 3, adding plus 3, minus of x plus 1 plus 3 is lesser than or equal to 3 because adding 3 on both sides. So here LHS, left side value is clearly equal to given function. Okay, f of x here, which implies f of x is lesser than or equal to 3. So for every x belongs to R, here also for every x belongs to R. So what do you observe here? The function maximum value is 3. So maximum value of the function is 3. Okay, but at what point the maximum value is 3? So you can write here to obtain maximum of f of x to take modulus, this modulus x plus 1 is equal to 0. Either you can take minus or else you can take directly. So modulus x plus 1 is equal to 0. So x plus 1 is equal to 0. X is equal to minus 1. So we got the point. Now you have to find f of minus 1. Now f of minus 1 is equal to R else. Therefore, the maximum value is f of minus 1 is equal to minus of minus 1 plus 1 plus 3. That is nothing but minus of 0 plus 3. So f of minus 1 is equal to 3. This is the maximum value.
Sir,
Yes.
in the graph, is -1 the x coordinate?
You're asking about a graphical representation.
Yeah.
So when we see the graphical representation here, graph is not required, but when you see that, yeah. See, this f of x in the sense y. G of x means g of x or f of x means it is equating to y. So to draw the graph, y is equal to minus of x plus 1 plus 3. Fine. Now put y is equal to 0. So what are the x values we are going to get? Y is equal to 0 means x plus 1 is equal to 3. This is 0, this negative value take left side will get like this. So x plus 1 is equal to plus or minus 3. So x is equal to plus or minus 3 or else minus 1 plus or minus 3. So what are the x values, students? The points on x-axis. 2 minus 4. Yeah. So first you should take 2 minus 4. So minus 4 here, 2 may be here. I'm taking. Now, when x is equal to 0, what about y value? When y is equal to 0, we are going to get x values, okay, x intercept. Then when I take x is equal to 0, y value is minus 1 plus 3. Minus 1 plus 3. So minus 1 plus 3 means 2. Means what about the here? Sign negative. Negative nothing but here we will get like this. Here y value is 2 when x is equal to 0. So here we will get a maximum value. Yeah.
Sir,
Yes.
sir, we can't do this sum with the second method, sir, by differentiating.
So by differentiating also we'll do, but we are going to get a two different values. Here modulus will be there. Okay, modulus will be there. So based on the x values, we'll get to the derivative.
Yes,
So it's better to do method one alone.
yes.
Okay, like that. Right. When x is equal to -1, it will be increased. Sorry. See students, when x is equal to -1, maximum value is like this. When x is equal to 0, y tends to like this. So this is the graphical representation of given function. So what do you observe here? What is the maximum value?
Positive 2 or
3. Okay, maximum value will be 3. So the intersection on x-axis is at -4 at 2. The intersection point on y-axis is 2. So till like this, it will tends to maximum. It will be reached to 3 and 2. Then here, then like this. Clear, students? This is the graphical representation. Not required here graphical representation. So here also we got the maximum value of the function is 3 alone. So minimum value it will tends to minus infinity. Okay. Next, you can do these two. Like here yesterday I already done. So in this question, h of x is equal to sine 2x plus 5 plus 5. So here you have to write that since we know that sine 2x is lies between 1 to -1. Okay, now adding 5 on both sides, -1 plus 5 lesser than or equal to sine 2x plus 5 lesser than or equal to 1 plus 5. So this is nothing but 4 lesser than or equal, this is nothing but h of x lesser than or equal 6. Therefore, you have to write the maximum and minimum values of h of x are maximum value is first we 6 and 4 respectively. That's it. Is it clear, Sven? This solution is enough. These are the steps enough. Sin x is sin 2x lies between -1 to 1. Then the given function is sin 2x plus 5, so that adding 5 on both sides we get 4 to 6. Minimum value is 4, maximum value is 6. That's it. Next and all you can do. Then what about here? This question I can explain you after completion of this third question. So here actually it is neither minimum nor maximum. Okay. So till question number 4th subdivision, they did not given any interval, yet they given some particular interval -1 to 1. That we will discuss after the third question. Shall we do this question? Local maxima and local minima values. To find local maxima, local minima, for all this question, we can go through the procedure. First, to find f dash of x and equating to 0, we are going to get critical values like C1, C2. So then you can find f double dash of x, substitute these C1, C2 values. F double dash of x is greater than 0. Greater than 0 means minimum. Lesser than 0 means maximum. Okay, coming to first subdivision. F of x is equal to x square. Then differentiate with respect to x on both sides. So f dash of x is equal to x. For maxima and minima.
So can you solve, sir?
Yeah. So always remember, students, for maxima and minima, we have to take that f dash of x to 0. We have to equate into 0. So what is the x value we are going to get here?
Zero.
Right. So we got that critical point here, x is equal to 0. Okay, f dash of x is equal to 2x. For maximum minima, we have to equating this first derivative to 0. We will get the critical point, that is x is equal to 0. Okay, so after this, what shall we do here? Yeah. So in this question, is here they given any interval, students? They do not given any interval. Am I right? So whenever they do not given any interval, what shall we do here? So when we find the second derivative here, in this case, f double dash of x. What is f double dash of x? F dash of x 2x, f double dash of x is 2. 2 is clearly greater than 0. Even at the critical point, at x is equal to 0 also, f double dash of 0 value is what? Right side, 2. 2 is clearly greater than 0. When f double dash of f double dash, second derivative is greater than 0. So which implies, what about the function? Which implies f of x having maximum value or minimum value? Yeah, minimum. So at the, so minimum value. So what is that minimum value? Therefore, the minimum value is f of 0. Yeah, what is the minimum value, students? F of 0 is equal to, substitute this critical value in given function. The minimum value or maximum value is given by given function only. Substitute the critical point in given function, that will be either maximum or minimum, but here f double dash of second derivative is greater than 0. The function having minimum, the minimum value is f of 0 is 0 square, that is 0. When we observe the graphical representation also, the graph of the function f of x is equal to x square is, this is the graph. See here, the minimum value is 0 at 0. Okay, x value is 0 and y value is 0. X value is point of minimum. The value is 0. So when x is equal to 0, y value also 0, right? So this is the required answer. Minimum value is 0 at x is equal to 0. Next, second one. What is the second question? X cube minus 3x. It is a cubic equation. Let's see here, cubic equation. F of x is equal to x cube minus 3x. So g of x. So let us see whether this cubic equation is either having maxima or minima. See, first what shall we do here? Differentiate. What is g dash of x? 3x square minus 3. Now for maxima and minima, g dash of x equating to 0. So 3x square minus 3 is equating to 0, right? So then 3x square, 3 is common, x square minus 1 is equating to 0. So 3 not equal to 0, but x square minus 1 must be equal to 0, because right side it is equal to. So x plus 1 into x minus 1 is equal to 0. So which implies x values are either 1 or minus 1. So here we got two critical points, 1 and minus 1. Now I'm going to find the second derivative. Second derivative. Again differentiate. Differentiate. G double dash of x is equal to, when I differentiate again 6x, am I right? What is the derivative of this 3x square minus 3? 6x minus 0, that is simply 6x. This is g double dash. But at the given critical point, so what are the critical point we got it, or the critical points? Critical points. So at this critical points, we have to find g double dash of x value. So at x is equal to minus 1, what about g double dash of minus 1, student? Yes?
Minus 6.
6 into minus 1, that is minus 6, greater than 0, lesser than 0.
Less than 0.
Lesser than.
Which implies what about g of x? Having maxima or minima? Lesser than means?
Maximum.
Maximum. Lesser than 0 means maximum. What is that maximum value? The maximum value is given by substitute it, this x is equal to minus 1 in given function. G of x is equal to x cube minus 3. Therefore, here itself I am writing the maximum value is g of minus 1 is equal to minus 1 cube minus 3 into minus 1. Okay, so g of minus 1 is clearly equal to minus 1 plus 3, that is 2. So at x is equal to minus 1. So the point of maxima is x is equal to minus 1. The maximum value is 2. Okay, the maximum value is g of minus 1 is right. In the same way, there are one more critical point is there, that is x is equal to plus 1. So at x is equal to plus 1, then what is g double dash of 1 plus 1, student? Yes, this is g double dash of x. So 6 into 1, that is 6. 6 is greater than 0 or lesser than 0? Clearly greater than 0. So whenever it is greater than 0, then what can we conclude here? Whether g of x having minimum or maximum?
Minimum.
Which implies g of x have minimum value. Minimum value. Therefore, Therefore, what is that minimum? Therefore, the minimum of g of x at the point of minimum at x is equal to 1 is g of 1 is equal to 1 cube minus 3 into 1. So that is the value is minus 2. The point of minima is, what is point of minimum? Point of minima is 1. That's it. Is it clear? So in every problem we can approach this procedure. First, take the given function, differentiate, equating to 0, we'll get the critical values. At that critical values, we have to find the second derivative. Okay, we have to check the second derivative at the critical point. If it is lesser than 0, opposite, the function having maximum. If it is greater than 0, the function having a minimum. That's all. So the maximum and minimum values are given by substitute the critical points in given function. That's all. Like this. Any doubts, students? Then the next question. Right. The next question is, right. Third subdivision is sin x plus cos x. Here the given interval clearly 0 to 90, first quadrant. So in first quadrant, we have to check the maximum and minimum value of given function sin x plus cos x. So here also what shall we do here clearly? So we have to differentiate equating to 0. We'll get that. See, already in this question, when you observe here, clearly the given interval that is 0 to 90. In previous questions, they did not given that interval, but here they given interval. So whenever they given the interval, is it necessary that to find the second derivative? Not required. Yeah, no need to find the second derivative. Okay, students. Simply you can substitute these values, end point 0 you can substitute, to pi by 2 you can substitute, and if you get any critical values, critical point, that point also you can substitute. Yeah, I'll explain you. H of x is equal to cos x plus sin x, 0 lesser than x lesser than 90. Right, first h dash of x, differentiate, minus sin x plus cos x. After that, h dash of x equating to 0, that is minus sin x plus cos x equating to 0. So cos x is equal to sin x. For what value of x? Both will be equal. Otherwise, we can write like this: cos x by sin x is equal to 1. Cos x by sin x nothing but cot x. Cot x is equal to 1. Yes. Then cot x is equal to 1 can be written as cot pi by 4. Even cot 225 also becomes plus 1. Am I right? Cot is positive in third quadrant, 225. But is that 225 belongs to given interval 0 to pi by 2? No. So according to the given interval, here given interval is clearly 0 to pi by 2 open interval. So when I cancel these two, x is equal to, which implies x is equal to pi by 4. Clearly it is belongs to the given interval 0 to pi by 2. 0 to pi by 2. It is not necessary that to check maximum and minima. Here very simple. You can substitute the values 0, pi by 2 and pi by 4. Clearly the critical point pi by 4 belongs to the given interval. So now at first x is equal to 0. What is the given function value? Substitute in given function, sorry, h of x is given now. At x is equal to 0, h of 0 value you can find. At x is equal to pi by 2, you can find h of 0. Okay, as well as at x is equal to pi by 4. Critical point also you have to find h of 4.
Sir, excuse me, sir.
Yes.
Sir, in the given question, sir, 0 and pi by 2 are not included in the sir.
Even though you can find, because they're asking maximum value, no, it will almost to 89.999 up to we can take,
Okay, sir.
but we can take 90 also. This is open interval, we should not include, but even though you can find those values. Yeah, all of you find this value, no? H of 0, h of 1. Local maximum, local minimum. Yes. So if you want to know, yes, here we can do actually in 2 ways. You can substitute directly. What about here values? H of 0, h of pi by 2, h of pi by 4. Okay, you can find these values.
Root.
Okay, otherwise, if you want to know exactly at pi by 4 whether it has minimum or maximum, simply find the second derivative. Not required. Again, if we do also, no problem. That is absolutely right only with help of second derivative test. So h dash of x, we got it minus sin x plus cos x. Now what is h double dash of x to ends? Minus cos x minus sin x. Sin x derivative is cos x is minus sin x. So after finding h double dash of x, what is the critical point? We got it pi by 4. So at x is equal to pi by 4, h double dash of pi by 4 value is equal to minus of cos pi by 4 minus sin pi by 4. So minus cos pi by 4 is 1 by root 2 minus 1 by root 2. That is minus 2 by root 2. 2 by root 2 means minus root 2. Minus root 2 means it is clearly lesser than 0. So what about the function at pi by 4? Yes. Which implies h of x have maximum or minimum? Maximum at x is equal to pi by 4. What is that maximum value? The local maximum. Therefore, the maximum value of h of x at x is equal to pi by 4 is, yeah, what is h of pi by 4? Sin pi by 4 plus cos pi by 4. So 1 by root 2 plus 1 by root 2. 1 by root 2 plus 1 by root 2, 2 by root 2. That is nothing but h of pi by 4 is root 2. Root is the maximum value of the given function h of x is equal to sin x plus cos x. Cos x plus sin x. Okay, what about h of 0, students? H of 0.
1.
1. H of 0 is 1. And h of pi by 2 also 1.
1.
Here root 2. So if you observe among these three, what is the value is highest value? 1 is highest value or root 3? Yes.
Root 2.
Exactly, root 2. So here also we got this is the highest value among these three. Is highest value. Okay, greatest value. So greatest value means according to the second derivative also, we found that At pi by 4 only given function having maximum value, the maximum value is root 2. So according to this, according to the interval, here the maximum value is again root 2 at pi by 4. So remaining and all, so the graph might be, we are going to get like this, here root 2. So here it is 1, here it is root 2. The graph we may get like this. Okay, like that. This is at 0, this is at 90, this is at pi by 4. At pi by 4 it is root 2. At 0 it is 1, at 90 also it is 1. So minimum value is 1, maximum value is root 2. That's it. Okay, students, you can try to do that remaining questions. All questions are very easy. So in all the questions same, differentiate equating to 0, we'll get critical points. Then we can differentiate again, we'll get second derivative. In that second derivative, substitute the critical point. If it is greater than 0, minimum, lesser than 0, maximum. Remember this working rule. So nearly 29 questions are there. In all the questions, we can apply this procedure, working rule, same working rule.